All right, so we're going to do optimization today in Calc 3, which is actually one of my favorite topics because it was one of my favorite topics in Calculus 1. Optimization, I think, is so vital, so important in certain jobs out there. How can I build a building the cheapest? How can I make the biggest profit on this return? So the whole thing with optimization is, this is what our world is in, okay? You will get hired to optimize something, either to make something the cheapest for a company or to make the most money for a company, okay? Some of you had me, some of you did not have me in Calc 1. So I just want to go over the steps that I taught in Calc 1. I had an acronym, and it was GLITTER. Okay, and we even mentioned this in class a couple of weeks ago, I think, because I think Hannah remembered glitter, and so did Derek. So, G is the given. So I want to write down what the given is, and you do not have to solve it this way. You solve your optimization however you want, okay? But I did G was my given, and then L is what would you like to optimize? So you have two equations so far. One has everything in it, the given one. And then the next equation is the one that you're actually going to want to take the derivative of. Now from there, I isolate one of the variables. And that comes from the glitter part here. The G is what you use to isolate one of the variables. And then you change that equation that you want to optimize, you transform it into a one variable equation. So the whole idea is you might want to optimize the maximum product of the numbers x and y, but you don't know how to take the derivative of a product equaling x and y because it's two variables. Again, this is Calc 1. So what you do is you take another equation and you help transform the x times y into an equation that is x times something about x. So somehow you can rewrite the y in terms of x, and then you can blend it in that you only have one variable when you're trying to take the derivative. So the IT part there forces things into one variable because that's all we could handle in Calc 1. Now obviously we can handle more than one variable here, and I'll explain that today. Then you take the derivative, set equal to 0, and evaluate where you get the critical point. And then you need to make sure that that critical point is the maximum or it is the minimum of whatever equation you're trying to get. And that's how you review by verifying you found what you want. Imagine if you're trying to get a company the max profit and you found the minimum profit, you would be fired immediately. Okay? So that's how I always did optimization in Calc 1, glitter. I don't care how you do it, but I do expect that right away you should be able to handle this classic Calc 1 question. So I'm going to hit pause. You're going to solve it. When you think you have it done, unhit pause, and you'll see my steps through glitter. Okay? Just make sure you guys saw it okay, that it is an x by x by y. Okay? And when it talks about your combined length and girth, it is your wraparound plus the length. So the x, so it's the wraparound part and the length. Okay, so if you're not quite sure on that, the wraparound x plus the y is 108. So if you need to pause again, you can if you need to try that out. So there's my given. Okay. What I would like to have is the maximum volume. Right there it says I want the maximum volume. So that volume is x squared times y. Okay. So x squared times y, I cannot take the derivative of that, okay, because it has two variables. So I isolate from the g, and I said y is 108 minus 4x. Okay. Then I can take that and plug it back into my volume equation. So instead of x squared y, I'm going to have x squared 108 minus 4x. Okay. Now I have an equation for the volume in terms of one variable. And if that's the case, I can then start taking derivatives and solving. So I take the derivative, set equal to 0. Let's see, you can pull out a 12x. That's what I have left. So one answer is x equals 0. That's stupid. If x equals 0, then you don't even have a box. So then I just found there my minimum volume. So the other one must be x equals 18, which means y is 36. And my volume is that. And the way I check is if I take the first derivative and I go with the second derivative of that, that's pretty nice. And at 18, my volume is negative, so it's a maximum. Okay? So that's a Calc 1 problem. Hopefully, again, sorry if you did not see, you hit pause too early and you didn't realize it was a square rectangular box. I should have put that up there to begin with. Okay. So there you go. All right. Now we're going to do it again in 3D. Okay. So what I mean by 3D is upgraded variables. Okay. Because a box is in 3D, but I'm going to have 3 variables to start with. Okay. Now notice this whole section says extreme application of extreme functions of 2 variables, and yet I just told you you're going to start with 3 variables, because I want you to realize Calc 1, how many variables did I start with right here? I started with 2, but then what did I have to do? I was able to put it down into 1. Okay, and that's all you can handle in Calc 1. So in Calc 3, I'm going to start you with 3 variables, but we're going to merge it down into 2 variables and kind of do what we did on Monday. Okay, so let's see this one here. The sum of the length and the girth, perimeter of a cross-section of a package carried by a delivery service cannot exceed 108. Find the dimensions of the rectangular package of the largest volume that may be sent. Okay, this time, not square base. Okay, I'm going to upgrade it to a not square base. Okay, and so let's go with it being any dimension that I want. Okay, so I'll call this X, Y, and Z. If you remember all of my Calc 1 questions back last year, everything had to be a square base, a square base, a square base. Well, this time, not a square base. It can be any set base. Okay. Okay. So again, when it says my length around perimeter plus the length, sorry, the girth plus the length would be something like wrap around and back. So the wrap around would be Z, there's a Z, there's a Z, there's an X, and the back is a Y. So I could say my given is 2X plus 2Z plus Y equals 108. Okay? and I would like to have the largest volume, so max volume, which is x, y, z. Okay. Now you know how to take derivatives of multivariable. Okay. We've done it with lots of variables, but I still want to get it down to only 2 variables, and you'll see why here as we keep solving. So the g goes to the I. Okay, so my given, I want to isolate one of my variables in my given. The y is by itself, so let's just go with the y. And I could say y is 108 minus 2x minus 2z. And if I take that and I transfuse it into the like equation, I could say volume is x 108 minus 2x minus 2z times z. Now I'm in 2 variables. And that's going to be nice because if you remember yesterday when I taught you how to discover critical points and you had to do the second partials, now I can do second partials here with the x and the z. I can't really do second partials with an x, a y, and a z. Okay. What I would do from here is I would distribute out just a little bit. Makes taking derivatives a little bit easier. 108xz minus 2x squared z minus 2xz squared. Okay, so this is the guy I'm going to take the derivative of. Okay, and I'm going to put a word here that we've talked about in the last couple weeks, just to remind you what can happen. Okay, it's symmetric. Stare at it. The 108xz, if I switch the x and the z's all the way through this, it would still be the exact same equation because especially the second and third terms there, the 2x squared z and the 2xz squared, they're the same guy if you switch those around. What that should mean, and I'm going to prove it to you, but what it should mean is, in the end, x should equal z because they are switchable. Okay, but I don't want you to say that yet. I just want us to show it. But I want you to cue in on that to realize, ooh, that is what should happen. So, okay, so now we have this. So now we can take derivative. And find critical points. Okay, so let's do the Vx. Now we're back into basically what we did yesterday. Everything now is what we did yesterday. So the Vx would be 108z minus 4xz minus 2z squared. And I want to set that equal to 0. Okay. All I would do for right now is pull out, let's pull out a negative 2z, and I would get out of that, I'm going to kind of rearrange things, z plus 2x minus 54 equals 0. I'll come back to that in a second. And then the other guy I would have is the z, which is 108x minus 2x squared minus 4xz equals 0. I'm going to pull out a negative 2x this time, and I'm going to get x plus 2z minus 54 equaling 0. Notice these are dumb critical points. This one's saying, whoa, where did I go? There we go. Oops, sorry about that. this one's saying z equals 0. Well, then that means your volume is 0. Here, x equals 0. That means your volume is 0. Those don't help me at all. Okay? So the stuff that helps me find the true critical point is setting this equal to 0 and setting this equal to 0. Okay? And again, notice the symmetry. Okay? So, let me just line them up a little bit. I got z plus 2x minus 54 needs to equal 0. At the exact same time, I need this guy to equal 0. Okay. Let's see. What could we do? What could we do to solve this? Let me rearrange so you see the lettering lining up correctly. This is a 2z plus x. So what could I subtract? Let's just go with, let's subtract straight here and see what we get. 2x minus x is an x. Z minus 2z is minus z. And minus 54 minus a minus 54 is 0. And you see what I had already told you before, because the equation was symmetric, way back up at the top. I already knew it, but I wanted to show it to you that x equals z. Okay? So, if x equals z, what can we do from there? Well, if x equals z, let's replug in and say, hey, I'm going to just take this guy and say this is x plus 2x minus 54 has to equal 0. 3x has to equal 54. X has to equal 18, which means z equals 18. Where am I going to go to get the y? What lettering of my glitter would I go to get my y? Where does y equal something? Okay, what about right here? Y equals, okay, on the I part, because I isolated it. So if I plug in 18 to the y part, you get 36 for the y. And length times width times height, that gets me 11664 for my volume. Okay? Now, that was all of the evaluating part. And the last part I want to check is making sure I found a maximum. Okay? So you can do this by checking with the second derivative test, the Calc 3 style. Okay? So Vxx would be minus 4z. And if I know z is 18, that's minus 72. Vzz, negative 4x, plug in, negative 72. Vxz equals negative 4x minus 4z plus 108. If I plug into that, I get negative 36. And then I do the little formula check. Negative 72 times negative 72 minus negative 36 squared. And that turns into a positive. So the d is greater than 0. And Vxx is less than 0. So I have a max. Now, the part you better remember from yesterday is the d part here, all of this. Okay, I know we did those tests yesterday. Okay, so just pull those out to make sure you have them fresh when you're trying to verify that your answers are what they're supposed to be, maxes or mins. Okay. Okay, so on the next video, we're going to try out one that is not symmetrical.